Hey guys, it's Mr. Wynn, and we're going to talk about Unit 5, Section 4, Radical Expressions and Rational Exponents. So our essential question, how do I write radical expressions? Those are the type of equations we've been working with, your square roots, key roots. How do I write radical expressions as radical exponents? All right, so we're going from radical exponents to rational, and I wrote that wrong. So as rational exponents, sorry about that. But we're going from radical to rational. Rational are those fractions, radical are the square roots, all right? So you should go over exponent rule first. So that's what I'm gonna do first. I'm gonna talk about the exponent rules. Basically, this one is saying when you have x squared and you're multiplying it times x to the third, you add the exponents. So 2 plus 3, 5. All right, when you multiply, as long as the base is the same, a to the m times a to the n, you do a times n plus n. If you divide, like say x to the third over x squared, you subtract the exponents. 3 minus 2, x to the 1. And if you raise it to the power, so a power rule, you have, let's say, it could be anything. It could even be like a number as your base. 2 to the third, I'm multiplying it to the fourth. That would be the same as saying 2, 3 times 4, 12. All right, you multiply those exponents. Okay? The new rule here we're going to talk about is the rational exponent rule. So if I have a to the m over n, that's the same as the rational, right? The radical expression of a to the m. So let's look at this. Where are my examples? All right. So that's saying if I have, like, say, the square root of x, well, we don't want squared. That's just going to cancel. How about x to the third, right? This would be the same as taking it as a fraction where I have x. The 3 goes on top. The n, the number on the outside, which would have been this 2, goes on the bottom of your rational exponent. So you're just kind of rewriting this, and it's the same as saying the square root of the x to the third is the same as saying x to the 3/2. All right? So if I looked at this, right, just a normal square root function is actually going to be x to the 1/2, because this is technically a 1. 1 goes on top, 2 goes on the bottom, 1/2. Square the cube root of a graph would be x to the 1/3, because you got a 1 here, 1 goes on top, 3 goes on the bottom, right? We're just kind of rewriting it. That's one of those rules, and it just works out, okay? So right here, these examples, we're going to convert these radical expressions into rational exponents, and you're going to see a little bit of mix of those exponent rules, all right? So right here, this is the square root of x to the third. So we know that there's going to be a square here. So if I rewrite this, the x, 3 is going to go on top, all right? As an x, as a fraction, a radical, 2 is going to go on the bottom, 3/2. All right? Same example, I realized. But example 2, 5 will now be on the top, 3 on the bottom because it's a cube root, right? Simple enough, just rewriting, right? What if I have these rules? So now if I rewrote this, right, now I have x to the 3/5. I am multiplying it by x to the 7/5. Remember your rules. This would now be x to the 3/5 plus 7/5. So you're supposed to add those, which then turns into x to the 10/5. And what's 10 divided by 5? 2. So your answer would be x squared, right? So remember, we're using that multiplying exponent rule. You multiply two bases that are the same with exponents, you add the exponents on top. So our bases were x, we add the fractions on top, right? So you may end up with something like x squared. It can be reduced down. So don't just add it up and leave your answer as 10 over 5, right? Simplify it all the way, all right? One last example. Okay, so if I rewrite this, cube root of x squared is going to turn into x to the 2/3, right? We're setting up as a rational. rational exponent. And then you have to multiply it to the 6, right? You're raising that to the 6. So remember now this, we had to multiply these. So we're multiplying that. It would be x 2/3 times 6. You actually just multiply the numerator. That gives you 6 times 2 is 12 over 3. And if you divide 12 by 3, that's x to the 4. So that can be simplified as well. All right, and that's it for radical expressions as rational exponents.